Good afternoon, students. This is Shiva Krishna, working as a assistant professor in Civil Engineering Department, Anurag Engineering College. Now we are discussing about the Unit 3, third unit, that is beams. What is the beam? In here, we have to find out the beams, cross sections, and types of beams, and types of sections, and what type of beams, what type of members should be involved in that, and what type of moment should be acting on that beams. You should be categorized in this chapter. So we are coming to syllabus. Here in the plastic moment and classification of plastic moments, and how to define that plastic moments, and section modulus, and this section modulus how to apply on the beams, and like continuous beams and simply supported beams. These types of beams, it should be learn about concept of this oriented total. It should have to maintain on that particular structure, like roof structures. It should be categorized into four parts, like purlin design. This all members should be capable to plastic moment. In here, in this chapter, first of all you have to introduce the what are the beams and what type of sections I have to provide in that particular truss or purlins or tension members. In this situation, what type of sections you have to provide on that particular location, and what is the buckling behavior phenomena occurring on that particular sections, like plastic moments and section modulus. These types of action should be acting on that particular locations, how to determine on that, and it should be categorized into two parts, that is laterally supported and laterally unsupported beams. And what is the design of laterally supported beams and build-up beams? Build-up beams means we have to build up that sections, and after that curtailment of that plates and web buckling and web crippling. So this type of channel sections it should be provided on that particular location. How to it connect the various components, and how to connect the various members on that particular structure. What type of what is the shape involved in that particular situation, and what type of member should be capable on that particular location, we have to see in this here. See here, I sections, channel sections, cross sections, and bolted connections, and sloping. What is the slope provided on that particular location? These all are here involved in this particular figures. Now various terms used in the beam members, that is first of all joist. What is the meaning of joist? Means a structural member provided in the building to support roof. It is also known as beam. It is a one structural member. This should be provided to building support of a roof. And what is girder? It is a large beam which supports a number of joists. It is basically build-up section. It should be involved. And purlin means it is also one of the beam and supports the roofing material of the particular truss. And angle and channel sections are used for these purlins. And what is the lintel? Lintel is it is a beam which supports a load of masonry on over openings. And plate girder, what is the gantry girder? What is the main difference between the plate girder and gantry girder? It is the build-up flexure member made up of the plates provided when rolled I sections are insufficient to carry loads. And gantry girder means when the loads, moving loads capability is very high on that particular location. In the situation, we are providing the gantry girders. This is the steel joist. Steel joist means here the combination of two materials. We have to provide the link between the two dissimilar materials. It is called joist. And girder, see here, this is the I section girder, this is the web plate, and this is the flange plate, and bottom side also we have to provide the flange plate. It is the connection between the two flanges with one web plate, that is called I section. See, these are the purlins. What is the purlin? It is a supporting of a roof member. Okay, that is called purlin. Here, one principal rafter should be capable to load bearing stamina. In that particular situation, the purlin also, it is the inclined motion, it is called purlins. And next one, lintel. See, this is the lintel is a small, it is the roof surface of the small opening that is called lintels. And these are the plate girders and gantry girders. This type of plate girders we have to provide on that particular bridges or particular barrages and particular bridge locations. On the railway tracks, we have to maintain the discontinuous bridges anywhere that should be provided on that plate girders. And these are the gantry girders. See, this is the cross section of that material. First of all, the topmost surface it is called roof truss, and two dissimilar materials like sliding it should be involved. Wheel rail means it should be rotating operation, and the two materials it should be located on that particular situation. The wheel rail should be provided in this particular situation. This is the main difference between the plate girders and the gantry girders. It should be moving loads. When the vehicle should be passing on that particular situation, it should be jumped up and down motion. In that situation, the total load should be carried distributed equally on that particular situation. See, these are the cross sections. First one is the eye sections. It is a combination of one web and two flanges, and the second one is that is also eye section. Here the first two figure, the depth of the web is very more. Here the flange width should be less. Here the web plate is also very high length, and flange plates also, width of the flange also very high. Third one, channel section, C type, it should be letter indicated to C. So this section is called channel sections, and inverted L means angle sections, and T sections, and like rectangular, circular sections. What is the behavior of beam under loading? See here, one particular straight beam, it should be load applying on that particular situation. The beam will be bent on that particular location. This is called bending, and it is occurring on the common phenomena on the beams. Here, three types of main configurations we have to conclude that is, one is the elastic flexural behavior, and yield movement, and plastic flexural behavior. In here we have two important terms we are discussed here, that is the plastic nature and elastic nature. In here, that total elastic nature should be converted into plastic nature. See here, first of all we have to take the eye section. The station diagram will be developed like this only. That first figure we have to show in the elastic behavior, and last we coming into plastic behavior. Here, by using the moment formula m by I, sigma by y, and E by r, from that equation we are getting the modulus of moment on that particular section, and that moment of section we should be converted into I by y, that is comes under modulus section. So yield moment form means Z into Fy. Z means modulus of section. See here the plastic flexural behavior. First figure it should be represented as elastic behavior, and this elastic behavior should be converted into plastic zone that should be represented as a rectangular motion. These two types of phenomena may be occurred in that particular loading situation. Based upon this, the section should be classified into more times, number of times. That is, it is a beam design. It is necessary to see the plate element should not buckle locally due to compressive stresses before beam can develop a full flexural capacity. How, depending upon the classification, the section will be classified into four categories, that is plastic section, compact, semi-compact, and slender. What is the plastic section, what is the elastic section, and what is the compact section, what is the semi-compact section? Here coming to plastic section, see on the page number 17 in the IS 800 2007, the table should be represented as deciding the classification of section. This classification, like see last three columns, class 1 represented as a plastic, and class 2 represented as a compact, and class 3 represented as a semi-compact. Here, how to define on that? This two, the total cross section will be depending upon the B by TF. B means width of the flange and TF means thickness of the flange. Based upon that values, we have to finalize the this section should be categorized under either plastic, either compact, either semi-compact. Epsilon here epsilon it should be coming to what is the range section type, it should be flange criteria and web criteria. In that flange criteria it should be find out the B by TF, and web criteria it should be find out the D by TW. In that plastic section, B by TF less than 9.4 epsilon. Epsilon means under root of 250 by Fy. The Fy, the value should be implemented as 250 only. So the epsilon value always 1. In here, the web criteria, I have to checking the web criteria, it should be less than 84 epsilon. For compact section, 9.4 to 10.5 epsilon. For web criteria, 84 to 105 epsilon. Based on these values only, we have to finalize the section that is plastic, compact or semi-compact. Coming to semi-compact, 10.5 epsilon to 15.7 epsilon. Coming to web criteria, 105 epsilon to 126 epsilon. More than this, it can be converted into total elastic, that is called as slender column. See, this type of identify the following sections. ISLB. ISLB means Indian Standard Low Beam. I means it should be represented as a I section. That is the depth, I section depth 450 at the rate. Unit weight of that member is 65.3 kg per meter. And ISLB, Indian Standard Low Beam, 600, it is the depth of that beam at the rate 99.5 kg per meter. That is the self weight of that section. And ISWB 600 at the rate 1311.6 Newton per meter. These are the some of the more examples. And you see here that plastic movement should be strain analysis should be coming into this type of plastic, semi-compact, compact. This shown in the figure. See, this is the laterally supported beams. One is the RCC beam slam. It should be supported with one beam. Okay, that is laterally supported. So we have to support given which direction, lateral direction we have to provide on that particular figure. See here, some of the jocks also we have to provide for moving vehicles. See, these two I sections connected with bracings. So this is also I sections is called beams. These two types of beams we have to provide with some bracings. You have to give the connections of welding or bolting. See, lateral supported beams means laterally we are supporting on that particular location. Next, cast-held beam, and see here is the practical view. What is the design consideration for this beam? First of all, you have to find out the bending moment of that section, and after that we have to find out the shear force of that section, and we have to find out the deflection of that section, and bearing stress and buckling criteria you have to provide on that particular situation. And next very important factor, that is web buckling and crippling. What is the meaning of web buckling and web crippling? Web buckling, in that particular situation, the I section, due to that load acting on the beam, the web portion should be buckled or it should be gaining some bend. So this is called web buckling. And web crippling means in the corners or junctions or joints on that particular two plates are connected. In that location, the failure should be occurred. This type of failure it is called as web crippling. So this is the failure should be acting on that web motion only. Due to high vertical stresses directly over a support under a concentrated load, the beam web actually crush or buckle as these stresses. See, this is the web deformation, and this is first one figure is the web crippling, and the second figure is the web buckling. See, this total it should be plastic properties of that beams. here the beam section should be involved, and weight of that beam should be involved, and what is the cross sectional area of that beam, and depth of section of that beam, and width of the flange, and thickness of flange, and thickness of web, and radius of gyration, and section modulus. Plastic modulus also here included. Shape factor means plastic moment to sectional modulus. It is called plastic modulus, sectional modulus. This is called shape factor. This should be generally represented to 1.1 for I section, and rectangular for 1.5. Okay, this type of plastic properties, this should be totally available in the IS 800 2007 and steel tables. So here some of the beams are given in that IS WB 600, IS MB, and 550 starts on here, IS WB 500, and IS MB 450, IS MB 350, and these tables see up to most of the tables are there, and see these all figures you have to find out. ISLC also there, ISMB, ISJC, these are all. So by using these tables, I have to find out the bending moment of that particular section, and to determine the section modulus and design of that particular beam. Thank you students.